Hello and welcome to this video on types of chemical reactions. So there are 5 major types of chemical reactions. The first one is that we're going to talk about is going to be synthesis. And so synthesis is where we have individual things that we're going to combine into one larger compound or molecule. Decomposition is kind of the opposite of that. So now we have one thing and we're going to break it apart into 2 different things. With combustion, we tend to have some sort of a hydrocarbon for the ones, we're going to talk about 2 different scenarios for combustion, but the classic combustion is really where we have something with carbon, hydrogen, and maybe some oxygen, nitrogens, things like that. And when we have those in the presence of O2, now here is the key. Combustion is going to have oxygen as a reactant, okay? Specifically, when there's a hydrocarbon, we're always going to end up forming this water and carbon dioxide on the product side. For a single replacement, what we see is that one individual thing is going to replace something that's equivalent to it in the compound. And so on the other side, it would be replacing that or displacing the thing that was in the compound. So sometimes this is called single displacement. And then for double replacement, they're just swapping partners. And so we see that between the 2 sides, that they're going to form with a new partner, and both of them swap partners. And that's kind of just a brief overview. We're going to really focus on the first 3 in this video and kind of give a little bit of an overview of the other 2. And in additional videos, we're going to really dive deep into single replacement and double replacement reactions. So here's an example of a synthesis reaction. So here we have magnesium and we have fluorine gas, and they're going to end up forming magnesium fluoride when they react. I guess I want an arrow there. Go. This should be an arrow, not an equal sign. And so if we were to do something that would be the opposite of that, so say we had something like aluminum oxide, and we wanted to take aluminum oxide and we wanted to make that back into aluminum and oxygen, that would be a decomposition reaction. So say we wanted to break something apart. So we could take something like sodium chloride, NaCl, and we could actually break apart sodium chloride into sodium, Na, plus chlorine. Now chlorine is a diatomic molecule, so we would have to have a Cl2, and then we would want to make sure that we balance this equation as well. Okay. For a combustion reaction, there's really 2 main ways that we can take a look at this. So burning those carbon-based compounds is kind of the first one. And so for an example of this, we would have something that would have a hydrocarbon. Okay, so carbons, hydrogens, possibly some nitrogens in there. And the big thing is that O2 molecule. Okay, it has to be a reactant. This has to be a reactant. If there is a hydrocarbon, so something with carbons, hydrogens, maybe some other things, on the other side we're always going to produce that water and carbon dioxide. Now, you might be saying to yourself, what about if we have oxygen as a reactant in a different situation? Well, technically it would still be considered to be a combustion reaction. And so a really common example of this is when we have magnesium metal that is burned in the presence of oxygen, and it ends up producing MgO. And so I have to balance my equation here, and I can use that metal oxide. All right. So finally, let's do a brief example of single replacement and double replacement. With single replacement, we just want to make sure that whatever we replace is equivalent. And we'll do a little more deep dive into this later. But say we had something like lithium plus iron chloride. So we'll say iron 2 chloride, Cl2. Okay. What happens is the lithium, as long as lithium is more reactive than iron, which it is, it will replace. So the metal or the cation has to replace the cation. Okay, that's really important. If it was an anion, it could replace the anion. I'll give you an example of that in just a moment. And so this would end up giving us iron by itself plus lithium chloride. Okay, we have to go through and balance this, and we can do that pretty quick and easily. Now, what if I had something like chlorine gas that was by itself, so Cl2 plus, we'll say lithium bromide. Okay. So in this case, the thing that would have to replace the other one has to be the equivalent, so it has to be the anion. Since chlorine is a nonmetal, we have to replace the nonmetal or the anion, okay, so with the other anion. It only happens if the thing that's by itself is more reactive, and we'll go over that a little more detail later on. And so this one we would end up with Br2 plus lithium chloride. Okay, and so those are two different examples of how we could see single replacement. For double replacement, this might be something like lead 2 nitrate, so PbNO. I'd like to use this one as an example. NO3 2 plus NaCl. Okay. And in this case, we're going to go ahead and react these, and we'll get PbCl2 plus NaNO3, and then we have to go through and balance this reaction, and we know this is actually a solid, everything else is aqueous, and this is a precipitate reaction. I hope that's helpful for you for an overview of the 5 different major types of chemical reactions.